Let's dive into the evidence statements front matter. This will give us an idea of how they were developed, how to use them, and especially how not to use them. I'm going to jump right to page 2. So the performance expectation here has all of the accessible components that we've been talking about. We can see the science and engineering practice, the disciplinary core idea, and the cross-cutting concept are all a part of the specific performance expectation for HSPS 1-1. The science and engineering practices in blue, the disciplinary core idea in orange, and the cross-cutting concepts in green. We know that this HSPS 1-1 is the accessible component. So this tells us what a student should be able to demonstrate understanding on. Well, that's good, but it's not as specific as we may need and to really understand what that looks like in a classroom or on an assessment. So that's the purpose of the evidence statements. These were developed for every single performance expectation, and it's really is intended to provide clear measurable components that, if met, fully satisfy each performance expectation described within the NGSS. What's important also is that any PE performance expectation is designed to be assessed at the end of instruction. And really, at high school, middle school, any grade level, it's by the end of that specific grade band or year. It doesn't have to be just as a freshman, you've been introduced to this concept. You might see this again as a sophomore, and it's really not until you're a senior that you have to demonstrate proficiency on it. So the purpose of these evidence statements really is to provide a teacher or assessor a true way to look at what a student should be able to do and demonstrate. And it's integrated by using all of those different components of a performance expectation. So we want to see all three dimensions. It should be completely intertwined. There should be evidence of the science and engineering practice, evidence of the disciplinary core idea, and evidence of those cross-cutting concepts. What's important is these are not curricula, and they're not intended to put limits on student learning. In fact, these are considered the floor. This is, at a minimum, what a student should be able to do. And like we discussed in the previous section, it's all standards, all students. So all students should be able to meet this level. Again, the floor, not the ceiling. Teachers can absolutely go beyond this in their instruction and expectations. So when we look at the structure of the evidence statements, they were developed using the science and engineering practices as the organizing structure. That doesn't mean that the practices are more important than the disciplinary core ideas or the cross-cutting concepts. It was just a way to scaffold because it's what students do. So if we're going to ask students to demonstrate or show their understanding, it should be through the doing part of that standard. In this case, it is the science and engineering practice. When you look at an evidence statement, so here's the evidence statement for the physical science performance expectation that we looked at just a little bit ago. You can see that it is framed around modeling because the performance expectation is about modeling. And if I have a performance expectation about modeling, I know that I'm going to ask students to look for the components of the model, the relationships within that model, and the connections in that model. You can see that the performance expectation really does start out here in our evidence statement with that science and engineering practice, which is in blue. And then scaffold within that, you will find the disciplinary core ideas in orange, and then again, the cross-cutting concepts in green. So let's talk about the idea that this is not just about teacher practice, right? Because it's not, we're not describing what teachers do or demonstrate, it's what students demonstrate. So a classroom demo isn't going to cut it for an evidence statement. It's really what students should be doing. And the templates and categories are not intended to be used in any of the following ways. So They should not be used as descriptions of increasing levels of cognitive difficulty. So this is not about depth of knowledge. It's all the features of evidence statements would have to be observed in order to infer proficiency. So just because you've got some doesn't mean that you've nailed that proficiency. It should not be a checklist. And so it's not going to go in order. You're not going to say, well, I'm only looking for the components here, and I'm going to check those off, and I'm going to teach only that. Then I'm going to talk about the relationships. It's not a checklist. And it's not an instructional strategy or a step. It's an instruction that builds towards any of these final performance expectations, and we would see evidence of that. They could be used, however, to develop that proficiency level. So if we know that a student should be able to demonstrate these skills around this performance expectation, I could use that to help develop a proficiency level for a rubric. However, I also know that all those performance expectations need to be bundled together when you're planning instruction or assessment. So it's never the intent that you're going to take one performance expectation and assess it alone. It needs to be combined with others into context. So when you hear about bundling, that's taking 2 or 3 of those, or maybe a few more, for an instructional unit and mixing and matching within those science and engineering practices, cross-cutting concepts, and disciplinary core ideas to finally assess on those performance expectations at the end of instruction. So we're always looking at the end of instruction, and these evidence statements are not a substitute for day-to-day lesson goals. That's something else, and there are definitely resources out there to help you develop day-to-day lesson goals, and we can talk about that another time. And yes, they are listed individually, but that does not indicate that you should be measured individually. Again, just as we talked, we're looking at a bundling, and it needs to be in context. There are limits to these evidence statements. They don't provide or prescribe the context, so that's when you come in. As a teacher, I'm looking at what I'm being asked to do as far as the science and engineering practices, so I know that students are going to have to model some things, they're going to have to ask questions, they're going to do some investigations, and it's going to be around some specific content, whether it be physical, life, science, and maybe a combination thereof. I could combine life science and earth science. And I'm really going to use those cross-cutting concepts to help get at student learning. But the context is up to me as an educator. So I get to think about that phenomena or that experience that students are going to learn about, in which I would apply those evidence statements. So I need to bring context to that evidence statement because that's the part that's truly missing. They do say that it's not sufficient to replace lesson plans or assessment items. They're not complete scoring rubrics, and it is, again, not a limit on coursework. The numbers that you'll find in them, so they'll say, here's component 1, and here's 1.1, 1.1a, has nothing to do with the order. It was just a way of scaffolding, so they don't indicate that it's different ways of depth of knowledge. It's just a numbering system, and that's it. That brings us to the development process and criteria. And we're going to kind of jump ahead to an example here. So I'm going to pop all the way over, let's start here, to the appendix of this document. This appendix is going to give us the general observable features of the practices by the end of 12th grade. So if I have a performance expectation with a science and engineering practice of asking questions and defining problems, I know that that evidence statement is going to be scaffolded with this information. So let's pop down here to our constructing explanations and designing solutions. We've been talking about ESS 3-4. Evaluate or refine a technology solution that reduces impacts of human activities on natural systems. I see that the science and engineering practice for this is constructing explanations and designing solutions. And specifically, it's about that designing solutions. So I'm looking at the engineering aspect of this science and engineering practice. If I now go over and look at this, here's the constructing explanations part, and then here's the designing solutions part. So I know that students are going to be asked to use scientific knowledge to generate the design solution. They're going to describe criteria and constraints, and they're going to evaluate potential solutions, and then refine or optimize a design solution or something thereabouts. Okay, I'm going to bring over my evidence statement. I can see right here, the frame is exactly that. Using scientific knowledge to generate design solutions, describing criteria, evaluating potential refinements. When I look more deeply, it has students use scientific information to generate a number of possible refinements to a given technological solution. When you think about that context, what is that given technological solution? So how do I take this evidence statement and really focus in on what I'm asking students to do? So what's the scenario around my instruction when I go to assess? So that they describe the system being impacted and how the human activity is affecting that system. So in this case, I'm going to describe what system. I would add this text as an educator to try and think about how I'm going to assess to see that students understand the system that's at play. So it doesn't matter which evidence statement it is, you're really looking for inputting that context. And that's how you can really use these evidence statements to help you in your instruction and eventually even developing rubrics.